In this video, we'll be going through part 3 and 4 of the January 2025 Regents exam, starting with number 31. Alex had 170 in nickels and dimes on his desk. There were 25 coins in all. Write a system of equations that could be used to determine both the number of nickels, n, and the number of dimes, d, that Alex had. Use your system of equations to algebraically determine both the number of nickels and the number of dimes that he had. This is a very common type of Regents question. They give us a situation and we are asked to write a system of equations. System of equations means two equations in this case. System means more than one. Okay, so we're given two kinds of information. One is about an amount of money, and the other is about the number of coins. So let's write an equation that represents he had 25 coins in all. We are told to use the variable n to be the number of nickels and d to be the number of dimes. So if he has 25 coins in all, that means the number of nickels plus the number of dimes must be 25. Now, let's make an equation about the amount of money that he has. We are told that he has $1.70. Now, for each nickel he has, he would have 5 cents. So we're going to say 0.05 n. That represents 5 cents per nickel. 0.05 times the number of nickels, plus 10 cents per dime. So a dime is 10 cents, so I will put 0.10 d. So that is my system of equations. Now, it does say to determine algebraically. That means solve for n and solve for d. For these questions, you should find the solution first on Desmos and write it down because that's already going to give you a point, even if you don't show any work. So let's do that. Let's graph our equations and see where they cross, and that will be the solution. So n plus d equals 25, and 0.05 n plus 0.10 d equals 170. Now, Desmos is going to tell you they're only going to support equations with x and y. So we'll use x and y, but I'm just going to make a note so we remember. Let's let x be the number of nickels, or n, and y be the number of dimes, or d. So when we have our solution, we interpret it correctly. Okay, so instead of n, I'm going to put x. Instead of d, I'm going to put y, just so Desmos can graph it for me. Now, this black line represents all the different ways that he could have 25 coins. So this intercept here represents all dimes, y-intercept. This is all nickels, x-intercept. And in between, for example, 10, 15, that's one way we could have 25 coins. The red one, the money equation, represents different ways he could have $1.70. So he could have 17 dimes, he could have 34 nickels, or he could have some combination in between, such as 16 nickels and 9 dimes. Okay, so let's find the solution. The solution is 16, 9. So x and y, right? X is nickels. So let's write down our solution. 16 nickels, n equals 16, and d equals 9. Now, do this first, so you have that, and as you show your algebraic work to try to get the other point, you also know what the solution should be, so you know if you're doing it correctly. Okay, so to solve a system of equations algebraically, there are two methods. We can do elimination, or we can do substitution. I'm going to show, for this problem, I'm going to show elimination. When I'm doing elimination, I want to get a term that matches in each equation, meaning have the same coefficient. So right now, for example, this one I have is just 1d, but this one is 0.10d. So I'm going to try to multiply the second equation by 10 so that I can get this term to say 1d so that it matches the one on top. So let's do that. I'm going to take the red equation. I'm going to multiply the whole thing by 10, and that means both sides. I'm doing that, again, in order to make this be just d by itself, so I can use elimination. Okay, so when I multiply everything by 10, every single term, left side and right side, I get 0.5 n plus 1d equals 17. And instead of writing 1d, I can just write d. So now I have a matching term. I have this one and this one. Both are just d. So this is helpful because now I can use elimination. So now I'm going to take the second equation, I'm sorry, the first equation, the blue one, and I'm going to subtract. The reason I'm subtracting is so that the d will be eliminated, and that's why it's called elimination. So 0.5n minus n, minus 1n, is negative 0.5n. When we're doing something like that, we are just subtracting the coefficients, and then in terms of n, so it's negative 0.5n. Okay, and then d minus d, that cancels out because it's 0. D minus d is 0. So we have successfully eliminated the variable d, which is good, because now we can solve for n. 17 minus 25 is negative 8. Now to solve for n, I divide both sides by negative 0.5. And I get n equals 16, so check. Now I need to go plug back in to solve for d. So I can do it for either of these equations, but the top one does look easier. So I'll take n plus d equal 25. If n is 16, I'll plug it back in here, because now I know n is 16. That means d must be 9, because 16 plus 9 is 25. So I got both solutions. I showed the work algebraically. Okay, next problem. The table below shows the average heart rate X and calories burned Y for 7 men on an Olympic rowing team during a 1-hour workout class. So I have average heart rate is X. Those are my X values on top. Calories burned is Y. This is my Y values. Write the linear regression equation. This is a key phrase here that models these data, rounding all values to the nearest tenth. State the correlation coefficient, another key phrase, rounded to the nearest tenth, and then we'll explain what the correlation coefficient means. Okay, there's almost always this kind of short answer problem where you have to write a linear regression equation and get the R value, or the correlation coefficient. For that, we will have to use Desmos. So I want to enter this data, so I'm going to go ahead and add a table. Enter all of your X values and make sure you keep it in the order it's given, because each X has its own Y. Okay, those are my X values. Let's enter the Y values. 725, 812, 866, 761, 825, 863, 737. And let me double check my X values. 135, 147, 150, 144, 146, 153, 143. Okay, I have all my data in the table. Now I'm going to hit this button, which says add regression. And by the way, it should plot the points. It'll make like a scatter plot for you. And just from the shape, I can predict that we have a positive correlation. Okay, add regression. So it's plotted the best fit line for me, which is the linear regression equation. And I have all the information I need here to answer this question. Write the linear regression equation, which is going to be this, that models these data, rounding all values to the nearest tenth. The only thing I have to do here is round the values. So the 9.11777 needs to be rounded to the nearest tenth. So I'm thinking the number 10 has 1 0. So the number of zeros tells me how many decimals I want in my answer. I want my answer to be just the 10th place. That means just 1 decimal. So I look at the next number over, which is a 1. If that next number over is 5 or more, I would round up. If not, I keep it at 9.1. So it would either be 9.1 or 9.2. It's in this case staying at 9.1. So that becomes 9.1, rounded to the nearest tenth. Let's round the other value. It's negative 527.55636. Nearest tenth, one decimal place. So I want one decimal place in my answer. It'll be either 0.5 or 0.6. Look at the next number over. 5 or more, so I round up. So this number will become negative 527.6. Those are my rounded values. So now I will have to use those values in the equation. Y equals 9.1x minus 527.6. That's my linear regression equation with the appropriately rounded values. State the correlation coefficient rounded to the nearest tenth. Correlation coefficient is the R value. It's right here. I need to round that to the nearest tenth as well. So 0.9022 tenth. Next one over is a 0, so I don't round up, or I round down. R equals 0.9. Explain what it suggests. This suggests a strong, two words we're going to use, strong and positive. Strong positive correlation. Okay. If R is positive, you say positive correlation. Oops. If R is negative, you say negative correlation. Strong is how close the R value is to either -1 or +1. So if you have like a 0.8 or a 0.9, whether it's a positive or negative, a 0.8 or a 0.9 will be strong. Okay, so the R value can be between -1 and 1. The closer it is to those numbers, the stronger it is. Positive or negative, you just check, is the R value positive or is it negative? So this one is a strong positive correlation, which you can visually see because the points are packed closely to the line. So there's a strong relationship between these points. If they were scattered all about, it wouldn't be as strong. So strong positive correlation. Okay, number 33. For this problem, we need to use the quadratic formula to solve this equation and express the solution in simplest radical form. Okay, quadratic formula is something that is in your reference sheet, as well as the quadratic equation. So if you forget A, B, and C, they're there too. So A is the coefficient of x squared, B is the coefficient of x, C is the constant term. To solve an equation using quadratic formula, it has to be the form ax squared plus bx plus c equals 0. So ours is already in the perfect form we need it to be to solve. So we don't have to do any algebraic manipulation there. Okay, so let's first identify A, B, and C. A is 1, because it's like 1x squared. B is 4, and C is -3. Those are my coefficients, and that is my constant term. Okay, now I'm going to use quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Now, whenever you substitute a number into the formula, use parentheses. This will help you avoid making mistakes with the signs. X equals -b, so now I'm going to put 4. Plus or minus, and make sure you show all of this work. This is how you get credit for this problem, is showing the work. B squared minus 4ac. Notice everything I substituted is put in parentheses. All over 2a. Now we simplify. -4 is just -4, plus or minus something. All over 2 times 1 is just 2. Now I'll simplify what was in the square root. Make sure to type it in exactly as it's shown. The answer here is 28, or the number under the radical, the square root. Okay, so that is my solution, but I want to get it into simplest radical form. Simplest radical form. Okay, so what we have to do is figure out how I can break this down. I'm going to think of factor pairs of 28, meaning what are two numbers that multiply to 28? 1 times 28, 2 times 14, 3, does 3 go into 28? No. 4 goes into 28. 4 times 7, 5 does not, 6 doesn't, 7 does, we have it already. So these, we're done. So these are all the factor pairs of 28. Now I want to find the one that has a perfect square in it. Perfect square, a perfect square here is 4. So I'm going to rewrite 28 using this factor pair because 4 is a perfect square. So on the side here, square root of 28 is equal to the square root of 4 times 7, which is equal to the square root of 4 times the square root of 7. Now you see the benefit of choosing the factor pair that has a perfect square because that will work out nicely here. It'll simplify. The square root of 4 is 2. So I have 2 times square root of 7, which you can just write as 2 square root of 7. 7 cannot be further broken down into any factor pair that will have a perfect square. Plus, the only factor pair of 7 is just 1 times 7, so we can't do anything with that. So I am done. So now I'm going to go back and rewrite this and use the fact that the square root of 28 is actually 2 square root of 7. I'm almost done. I'm going to see what else I can simplify. Since this whole thing is being divided by 2, it means both of those terms on the top are being divided by 2. So it's negative 4 divided by 2 plus or minus 2 root 7 divided by 2. Now I can simplify. Negative 4 divided by 2 is negative 2. 2 root 7 divided by 2, those 2's will cancel out because 2 divided by 2 is just 1, so these will cancel out. Plus or minus root 7. That is my answer. I don't have to figure out what the square root of 7 is. It's going to be an irrational number. So I'm going to leave it like this. That is what simplest radical form is. So here I am done. Okay, number 34. Solve the following system of equations algebraically for all values of x and y. Okay, it does say solve algebraically, but we know we should get our solution first, then go back and show the work algebraically. Even if you have the correct answer with no work shown, you will get a point. So let's write down that solution first. Okay, so let's graph each one. X squared minus 7x plus 12, and then y equals 2x minus 6. The solutions to a system are the points that satisfy both, in other words, where they cross. So these are my solutions. Notice how this is worded. It says for all values of x and y, so they want both solution points and they want x and y for each one. So we can write x equals 3 and y equals 0. That's this solution. That's one. And we can write x equals 6 and y equals 6. That's the other. Those are my solutions. Now let's show our work algebraically to get the other points. But we got a point here for having those solutions. Now, if both of these equations are equal to y, right, they both start with y equals, they must be equal to each other. So this is equal to y, and this is equal to y. So they must be equal to each other since they are both equal to y. So that's what I'm going to do. I'm going to say x squared minus 7x plus 12 is equal to 2x minus 6, since they are both equal to y. So instead of y, I could write x squared minus 7x plus 12. Okay, now I want to get the right side, or either side actually, but I want to get one side of this to equal 0 so that I can solve it as a quadratic equation. So what I'm going to do to get the right side equal to 0 is subtract 2x from both sides to get rid of that 2x there. And I get x squared, negative 7x minus 2x, negative 9x plus 12 equals, those cancel out, which is what I wanted, equals negative 6. Okay, now I want the negative 6 gone. I want the right side equals 0. So let me add 6 on both sides. I get x squared minus 9x plus 18 equals to 0. Negative 6 plus 6 is 0. Now, since it's equal to 0, I can either use quadratic formula or I can factor. In this case, I'm going to choose to factor because I can see that the numbers are going to work out. But you can also, at this point, you can use the quadratic formula if you prefer. So I need to think of my two numbers that will multiply out to 18. Those numbers, they will also have to add up to negative 9 since I want these to combine into negative 9x. So it's just going to be a bit of trial and error. You can list out pairs, factor pairs of 18, play around with the positives and negatives, but it's going to be negative 6 and negative 3. Those will multiply into 18, and they will also add up to negative 9. See these? They'll add up to negative 9, which is what I want over here. Okay, so the factors are x minus 6 and x minus 3. And by the way, a way to check for like factoring problems is doing this. Because when you factor, you should be getting an equivalent expression. So x minus 6, x minus 3 should be the same as x squared minus 9x plus 18. And look at that, they have the same graphs. So that's another thing to like know is like checking factoring problems with Desmos. Okay. Anyways, so it's equal to 0. So since this is a product here, x minus 6 times x minus 3 equals 0. I know 0 times any number will give me 0. So either this is 0 or this is 0. In that case, x would be 6. And in this case, x would be 3. Now to figure out y, I will plug it back into either equation. It should work. I'm going to choose the second one, the linear equation, because that'll just be easier to plug into. So in this case, y equals 2x minus 6. So 2 times 6 minus 6. Y equals 6. In this case, y equals 2x minus 6. Y equals 2 times 3 minus 6. And I get y equals 0. And that checks out with the solutions I found by graphing. Okay, so that's how you can show it algebraically. Okay, now we're up to the last question, number 35. The last question is always worth 6 points. So think of it as a way to earn a lot of credit. You have a lot of different ways you can earn points for the last question. It is almost always some kind of writing a system. Sometimes you graph it and sometimes you solve it and answer a follow-up question, but you have to know how to write a system of equations. That's definitely an essential Regents skill. So, Anna plans to spend $30 on balloons and party hats for her daughter's birthday party. Including tax, balloons cost $2 each and party hats cost $1.50 each. The number of party hats Anna needs is twice as many as the number of balloons. If X represents the number of balloons and Y represents the number of party hats, write a system of equations. There we go. That can be used to represent the situation. This is kind of like the coin problem in that we have two pieces of information. One is about the money. So we know she has to spend $30. We know the cost of each item. So one equation's about the money. The other equation is going to be about like the number of things. The number of party hats Anna needs is twice as many as the number of balloons. So I can see the two kinds of info I have. Each one of those I can write an equation from. Now let's see what variables we're going to use. If x represents the number of balloons and y represents the number of party hats. So I'm going to go back in the problem. Wherever I see balloons, I'll put an x. Wherever I see party hats, I'll put a y. The number of party hats Anna needs is twice as many as the number of balloons. Okay, let's write our money equation. $2 per balloon plus $1.50 per party hat is equal to $30. That's my first equation, the money equation. Next, I need the number of things equation. So I'll reread the sentence with x and y instead of party hats and balloons. So y is twice as many as x. That means y is twice as many as x. Twice as many means 2 times that amount. So y is twice as many as x. You can write it as y equals 2 times x, or y equals 2x. That is my system of equations. Okay, I'm going to graph it because that's what it asked me to do in the next problem. And it helps me find the solution, which when they have you write a system, they're going to ask you to find the solution. So here are all the ways she could spend $30. There's a lot of different ways she could spend $30, right? And here are all the ways she could buy twice as many party hats as balloons. Again, a lot of different ways. The solution is what satisfies both constraints. So it'll be where the lines cross. So that's my solution. Okay, let's use this to answer the next question. But for now, you should have a system written down, system of equations. Okay, graph your system of equations, state the coordinates of intersection, and explain what it means. Okay, time to graph. So when we're graphing functions, we are always typing in the function and then getting a table. Getting a table doesn't work if you have x and y on the same side. So what we should do is plot points. If we plot 2 points, we can use a ruler to connect them. And the best 2 points to plot, so we cover the whole graph, are the intercepts here and here. On exam day, you're going to have a ruler. So if you get those two and use a ruler to connect them, you should have the exact perfect line. And just a way to check is find another point and make sure it goes through it. So 612, I also want to go through the point 612. So let me make those 3 points and then connect them with a straight line. Make sure you use your ruler. Okay. So let's do the purple one. 0, 20. And 15, 0. And for good measure, let's get 612. So when you use a ruler, you should also be hitting that point. 612. Okay, I'm going to use the line feature here to make a perfect straight line. You should be using your ruler. There's my line. Okay, let's graph the other one. Oh, one more thing. We should label. Anytime we graph 2 things on the same graph, label them. So this one is 2x plus 150y equals 30. Labeled. Good. Now we're going to graph the other point. The other line. Y equals to 2x. Now, this is in slope-intercept form. The y-intercept, or b, is 0, and the slope, or m, is 2. And by the way, you are given this equation on your reference sheet, mx plus b. So just something to note. You can find slope and y-intercept. Slope is m, y-intercept is b. Anyways, we can use the graph here and just get some points and plot them. Like 0, 0, 2, 2, 4, 3, 6. Boop. You'll get it, but it's 3, 6. And then we can just plot them. But also, I'm going to use slope-intercept. It'll be just like easier for me to graph. So I have the y-intercept, and then the slope is 2. That means I keep going up 2 over 1. There. Up 2 over 1. There. Up 2 over 1. And you can like check it by finding the exact points to plot. Right? 6, 12. Okay, so let's do it. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Same slope throughout. And it should form a straight line. Again, use your ruler. I'm going to make my line. This is good. It crosses through 6, 12, so that helps me answer the next question. Okay, I'm going to label it. Oops. Now, if you label one, that is technically enough, but I'm going to label both. Because if you label one, they'll know the other one is the other one, but I'm going to label both. Okay, state the coordinates of the point of intersection of your lines. The point of intersection is the crossing point. We know that it is 6, 12. 6, 12. State the coordinates, meaning x comma y, 6, 12. Explain what each coordinate means. We have to say each coordinate meaning the 6 and the 12. So we have to say what each one means. Well, 6 is x and 12 is y. X was the number of balloons, right? X-axis, number of balloons. Y was the number of party hats, right? So we all we have to say is Anna can buy 6 balloons and 12 party hats. And that's it. You've made it through an entire Regents exam.